So let's know more about SEG software. It's an engineering application software. It's a design automation tool and productivity tool for 3D modeling and detailing of static equipment. By using SEG software, you have the ability to create the 3D digital prototype of your equipment and test it before manufacturing to check if you have any clashes or anything like that for your equipment. You can create your bill of material automatically by using SEG software. Actually, you will need Autodesk Inventor as a platform to be able to run SEG. By using SEG software, you can save up 80% from your time and money. We make an actual case for an equipment. This equipment we created by 3 methods. You can figure that we create all of those drawings by 3 different methods. The first one is the traditional method by using the 2D CAD software, and we create those drawings in 50 hours to generate the general arrangement drawing with all tables, notes, design data, welding details. The same for bill of material, manway detail, nozzle detail, nameplate, saddle, and the other details for this equipment. By using a CAD software like SolidWorks, Autodesk Inventor, CATIA, just pure CAD software, we consumed around 28 or 27 hours to generate the 3D model.
Sorry to interrupt you, Mr. Ahmed. Hello.
Yes.
Sorry to interrupt you. Your voice is not coming very clear and it's coming with a low voice. Can you speak some loudly and more clear?
Okay.
Hello. Yeah.
Okay. Okay. Now.
Yeah, now it is okay.
Now. Okay. Now it's okay. Okay. As mentioned, I will review this slide again. Here in this real case, we make the same equipment by 3 different methods. The first method by using a 2D CAD software, which is in this case was 2D AutoCAD. Okay, and we consumed around 50 hours to generate the general arrangement drawing, includes the nozzle tables, flange table, design data, notes, welding details, and to generate the bill of material, manway detail, and the other details as you can figure in this slide. By using a pure CAD software like SolidWorks or Autodesk Inventor, we consumed around 28 hours to generate the 3D model and the 2D drawings for this equipment. By using SEG software plus Autodesk Inventor, we consumed around between 7 and 8 hours to generate the complete 3D model and all of the detailed drawings for this equipment. And you can figure that the big difference between the consumed time by traditional way and by using SEG software. 50 hours faces 7 or 8 hours to generate the same drawing. So you can save about up to 80% from your time and money. And you can gain more projects depending on using the SEG software, because you will be able to minimize the consumed time to generate the 3D models and the 2D drawings and the fabrication drawings. Actually, you can use the 3D model on the finite element analysis, because the 3D model is created as a CAD software on Autodesk Inventor, so you can use the 3D model to make some analysis by using the finite element analysis tool in Autodesk Inventor or in Nastran in CAD or any other analysis software like ANSYS or Abacus or any other software. Okay, and you can use the sheet metal plates, as we will discuss on the next slides, to generate the nesting for your equipment or all of your project. By using SEG software, you will be able to generate many different types of equipment under one umbrella. By using SEG software, you can generate horizontal, sloped, and vertical vessels. You can generate columns with multi-sectional sections and different diameters, storage tanks with a fixed roof, heat exchanger according to TEMA, piping, ducts, and slug capture. Here are some of real samples generated by SEG software. As you can figure that we generate a storage tank with a fixed roof, and you can figure that the top and the bottom plate arrangement, spiral stair, manway and clean outdoor. And here's some samples of vessels created by SEG software, and you can figure that from small sizes to large sizes vessel you can create it easily. You can make a piping on the equipment easily. Some connections like or elements like the end closure. You can generate the TEMA exchanger types by using SEG software with many different types, and we will discuss it inshallah in another slide. In SEG software, we are depending on the construction tree. In SEG tree, you will build your equipment, and in this tree, you will define the equipment and each element inside this equipment. We have different levels on the tree. The first level is the project level. In the project level, you will define the project information like project number, project name, plant name, client, and many other information regarding to the project. Okay. After that, we will have the equipment level. In the equipment level, you will define the design data like construction code, internal design pressure, and if you would like to remove all of those information and define another information by yourself, you can import it by using import from Excel sheet. Okay. In the same level, which is the equipment level, we will define the equipment setting or the vessel setting, like the position of the vessel. If you would like to make it horizontal, sloped, or vertical, okay, and you will control the direction of the assembly. If you would like to make the assembly start from left to right or right to left in horizontal and sloped case, and if you would like to make it from bottom to top or top to bottom in a vertical case, okay. Here in the units, you have the ability to control your project units, if it in millimeter or in inches, and you have the ability to control the precision of units. Here on the details, you have the ability to define the service of the equipment, the tag number and the serial number of this equipment if you would like to export it to your drawing. And here for this field, it's a very important field, which is delivered blade data. By using those information for the delivered blade dimension, which is the length and width, SEG will use those data to calculate the circumference of the shell and calculate automatically the required number of segments to generate this shell. For example, if you have a large diameter, like 7 meters diameter, for example, in this case, the blade length, which is on our workshop, will not cover the total circumference of the shell. So we may need 3 or 4 blades to complete the circumference of the shell. So SEG will use those data to calculate automatically the required number of blades to generate the shell. By using Autodesk Inventor and SEG software, you have the ability to create your models, parts, assemblies, bill of material, nozzle opening, sheet metal, flat pattern, and many other things automatically without using a manual or hand update or hand modification. Okay. In SEG software, there is a tool for the storage tanks with a fixed roof. By using this tool, you have the ability to make the roof plate arrangement
Mr.
and
Ahmed,
plate
skip
yes.
this one.
Okay.
Yes, skip this one. This is not our product. You can elaborate one. Just a minute. Come again. Previous one.
Okay. Another
Previous
tool
one.
in SEG.
No, can you go back to previous
Mr.
slide,
Ahmed.
Ahmed? Okay.
Okay.
One
Here?
more
Yeah.
previous. Yes, yeah. Can you just clarify this one? No, next one.
And
About
that
plate
nesting
cutting
part,
sheet.
that nesting part, can you just give them some idea? That
Okay.
slide which you shown.
Okay.
This
This
one.
slide?
Yes, this plate nesting.
Yes,
Yeah.
this is required. Can you just
Yes. Okay.
explain on this?
Yes.
Okay. There is a nesting tool Autodesk provided, so we can use it in SEG to generate the nesting for all plates in your project. SEG software create each plate as a separate plate, and you can get the flat pattern of this plate, and easily you can make a nesting for your equipment. As you can figure that here, we make a nesting for plates, and automatically by using this nesting tool you can generate the required number of plates and the efficiency of cutting, how you can save from your plates during this operation. And here that's a video for indicate to show you how to make a nesting for the annular plates. For example, we will open the assembly which created by SEG, and here we will make a nesting study for the plates. Let's click yes. And here the nesting tool from Autodesk will detect automatically the thicknesses of plates and the material of plates, and depending on that it will generate a study depending on the thicknesses and material of each plate. After making the nesting, you can figure that if we stop this, you can figure that after this process you can calculate the required number of plates and make a nesting for this. That's a bottom plate, and we can make the same nesting process on it. So let's modify this. Okay, so let's move forward here, and you can figure that after the nesting, those are the elements of the bottom plate, and here the nesting of those plates, and you can figure that here in some cases, in some plates, you will get some plates, 2 plates in one sheet, and the same here. And if we come back to the annular plates, you can figure that the nesting efficiency here, so it's around 80%, so you can save up this value from the plate dimension, and the number of total plates required, you will need 3 sheets, and in those 3 sheets you will get 12 parts of annular plates there. So by using this nesting tool, you will be able to make a report. Here you can generate a report for the nesting. Okay, and here you can export this report in a PDF extension, and here you can calculate the cost, many different things by using this tool. Okay, Another tool for the importing the exported CSV file from HTRI. Okay, so if you are using HTRI software in the thermal calculation, you have the ability to export the CSV file from HTRI, which includes the tube arrangement on the tube sheet. And we have an integration tool. This tool can read the exported CSV file and generate the tube pattern arrangement. And create, by using this tool, you will be able to make the holing for tubes and tie rods, sealing rods. Okay, we have another tool in SEG software. This tool, you can use it to generate the tube pattern arrangement. If you don't have HTRI software to use it to generate the whole pattern. By using this tool, you will be able to change the tube layout or the tube pattern, and the big point of the tubes changes the pass partition, and we will discuss this slide in deep in another slides for the heat exchanger. Okay, let's skip this slide. It's for the tube pattern.
Yeah.
Because we will discuss.
Sorry, Mr. Ahmed, just to interrupt you. Just I want to know whether this all data will come directly from PVLite or how is interaction? Because what I understand, you are going interaction with three softwares, no? SECAD, this Inventor, and PVLite. But from where are the PVLite data? I'm not able to understand how it is coming from PVLite, this data.
Okay. So SEG software includes a tool, integration tool. This integration tool have the ability to read the exported MDB file, which is an access file, access database file. This access database file, you can export it from BVLite. Okay, but this access file has some limitations. Like if you would like to export an information for a heat exchanger, no information will be exported for the tube sheet or the flanges of the tube sheet. So this tool in BVLite software has some limitations. But in Visuals, you can export a lot of information on the access database file. In SEG software, you can read this exported database file and convert it automatically to SEG3, which is the items, head, nozzle, supports like saddle, and we will check a video like that during this session, inshallah. But by this way, you have a 3D model on BVLite or a model on BVLite. You will export an access database file from BVLite. Okay. After that, by using SEG software, you will read this exported MDB file and convert it to a 3D model on Autodesk Inventor. And by the same, you will create the 2D drawings of this equipment. Okay. As we discussed, this access database file has some limitations, and we will clarify it during the session, inshallah.
Also, there is a development going to happen because we have already raised a request to Hegazy to have more information in the access file. At present, if you have a pressure vessel, then it will take almost all the data from PVLite. But when it is a heat exchanger, the tube details are missing at present in that access file. So that has already been forwarded to Hegazy, and there is a development. So we are expecting the same to happen in the come in the next coming version. That's what they have actually informed us. So it is actually under the development stage. So that will definitely going to get sorted out. But here you can take the tube data from HTRI also directly, or you can do all the detailing in the SEG itself. Fine.
Yes, yes,
Okay.
you are right.
Okay.
Okay, by using SEG software, you will get a complete bill of material list for your equipment and your project, and you can export it in Excel format. You can make a cost report for the material cost report, and you have the ability to export it in HTML format. Another tool in SEG, you can use it to generate the nozzle opening here. By using this tool, you can generate the nozzle opening on shell plates and head plates. So you can generate after that the sheet metal flat pattern by using another tool in SEG to generate the sheet metal flat pattern for all blades, like this support or this shell, including the nozzle opening. Okay, so those are different tools. Here in exporting options, you have the ability to export the 3D model.
Okay. You have shown one development of the plate. So can we do the opening before the rolling? Is it that so accurate?
What do you mean by nozzle opening?
Can we cut out the openings before the rolling?
Yes, yes. By using
is it that so accurate?
By using the holing process, you have the ability to define the clearance of the cut around the nozzle. Okay. After that, by using this tool, you will get a cut around the nozzle with the clearances that you defined, as you can figure here, there, and for each nozzle. After that, by using the sheet metal flat pattern tool, you will get a flat pattern for this sheet blade with all cuts, with all nozzle cuts. Is this point clear, or still you have any issues?
I want to just clarify how it is accurate. If I am doing the opening of the 24-inch nozzle while at the time of the plate cutting, and after doing a opening in the plate cutting itself, I will do the rolling, and after the rolling, should I get the exact dimension as I required for the nozzle opening? That is the Hello.
Actually, I wanted to understand your question in a correct way to answer you in a correct way.
I am repeating. I will repeat one more time. As per our conventional process, what we are doing is, whatever the cell core size is there, we do the plate cutting according to the required development length of the cell. Then after we do rolling and set up a long seam. After setting up the long seam and performing long seam of the cell cores, as per the nozzle size, we are performing nozzle cut. After performing long seam and all the things. So my question is, can we do the nozzle opening at the time of the plate cutting itself? And after the plate cutting, we do the rolling, and so that we do not have to do the nozzle opening cutout. So is it possible that we can do the nozzle cutout in the
as I understand
advanced stage of the plate cutting time?
Okay. As I understand, you are speaking about manufacturing and the process of cutting come before rolling or after rolling. Is that right?
Correct.
Okay.
Before rolling. Can I do the nozzle opening before rolling? Simple.
Okay. By using this tool, which is a sheet metal flat pattern, you will get a 2D CAD drawing, includes the cut, the accurate cut of the nozzle opening. Okay. So if you would like, it depends on your fabrication. So the fabrication or the labor who can tell you, is it possible to make it before or after? Not me, but the software will give you the correct nozzle cut pattern. So if you would like to make it before rolling or after rolling, it depends on your what I can say. It depends on your machines, not on SEG software. SEG will export it in a correct way. Cutting it before or after, it depends on you. Okay. I hope this point is clear now.
Have you performed this math process in the actual one? Have you did any trial this kind of?
Actually, from my side, as I know, after rolling the cutting, we do it. Because I am a static equipment design senior design engineer. I have an experience more than 14 years in this field. As I watched before, in manufacturing, we make the rolling. After that, after the rolling, we make the cut by using the sheet metal flat pattern. Okay, we will indicate the opening locations. After that, make a cut after rolling. Okay.
Oh, okay, Mr. Ahmed, you can proceed now. Yeah.
Okay. By using SEG software, you can export your 3D model in many different extensions to suit other softwares. If you would like to use another software in some process, you can export in step file, SAT file, IX file, ZGL file, XGL file, many different extensions, and the same for drawings. You can export your drawings in DWG or DXF extensions, PDF, and many different extensions. By using SEG software, you can generate the general arrangement drawing for the equipment, or the sub-assemblies, or details, or parts. And the drawing, you can include a lot of tables inside your drawing, like the bill of material table, design data, notes, nozzle table, flange table, and many other tables. For example, for the nozzle table, the nozzle table includes tag, nozzle tag, nozzle surface, nozzle size, the nozzle outside diameter, and many different other information. And you have the ability to select the required information that you would like to export it in your drawing. For example, in your drawing, you would like to export the tag, surface, and the size only. Okay, so you have the ability to select those information only to export it to your drawing. And if you would like to add, for example, the rebat thickness and or internal projection or external projection, you have the ability to add or remove the required fields which will be exported to the drawing. Okay, in SEG software, you have the ability to select your standard border from the choicer of the company border, or if you would like to create your standard border, we generate a new tool for that, and we will discuss it inshallah in another slide. By using this tool, which is importing reference drawing, you can import your reference template, which includes your title block and your border, and you can use it in your drawings automatically. In each drawing you will generate it, you will use this reference drawing. Okay. In SEG, you can find a huge library for standard welding details, and you can select from them to export it to your drawing. Okay. Here, that's the BV-Elite integration tool. In BV-Elite software, you will export the MDB file, which include some data of your equipment. And by using SEG software, we have the ability to read this MDB file and convert it to 3D model on Autodesk Inventor. After that, you will be able to generate your drawings for this equipment. Here in this video, quick video, we will discuss how we can do that. Here we generate a new project, and from import tool we will import the MDB file, and here with some information like the welding detail, longitudinal welding line orientation for each course, the saddle support. After importing the information, you can figure that the tree is created automatically in SEG. Now we will save all information by using the tree save button to save all information that we imported from the MDB file. And now we will generate the 3D model on Autodesk Inventor. Okay, now we have the complete 3D model. After that, you can make some customizations on this model, like modifying the support saddles to suit your fabrication requirements, add some attachments like the nameplate, because you know in BVLit no information for nameplate, so you can import a nameplate or some supports or some internals, modify the davit for the manway and the davit and bolts. Many other things you can add it to your equipment after importing it from BVLit to make it suit your application requirements. Okay, now we will go to another slide for the here that's for 3D modeling. We need to, so let's close this. That's for heat exchangers. Okay, here for TEMA heat exchanger, as all of us know that the TEMA exchanger type includes these three sides. The first side is front end, shell type, and rear end. By using SEG, you will be able to generate A, B, C, N types from the front end, and you have the ability to generate all types from the shell type. And on rear end, you have the ability to generate L, M, N, S, U types. Okay. For the front end, as you can figure, on the A type, for example, you have two different cases for the A type, and if you would like to make a modification or generate an odd shape, you can do it by making or creating the items separately on the SEG tree, and we will discuss that inshallah. And for example, for the C type, on the channel integral with tube sheet and the cover, so you can generate those types for the front end. And for the shell type, you can generate those types, all types on the shell side. And for the rear end, you have the ability to generate those types. For example, in L side, if you would like to make a channel like this or with a cone like this, and the other types of S, M, N, and U. Some most common types of heat exchanger, like AES, BES for the cattle type, or the AEM or BEM, so you have the ability to make that. By using the in this video, I will show you how to add items of the exchanger manually. If you would like to generate the exchanger element by element instead of using the exchanger tool. So as you can figure, we add a blind nozzle. After that, we add a gasket and flange. To generate a channel, we need to generate a channel, so we will add the items separately. So the channel includes blind, gasket, another flange, shell, flange. Okay, so we will generate those items separately and define the dimensions of each item on the tree by filling the data from the interface or the input data of the element. Okay, so you will select the element. After that, select the suitable type and fill the required data on each element. Okay, the benefits of using the exchanger tool, which is the parametric modeling or automated parametric modeling. By using the parametric modeling tool, you have the ability to equal some parameters with each other. For example, if you have an ellipsoidal head or a hemispherical head and a shell after this head, if you define the diameter of the head separately, it will not be reflected to the shell. So you will need to come back. Like in BVLite, if you change the diameter of the shell, it will change it separately. But here, if you would like to make a relationship between some parameters, like make the inside diameter of the head equals the inside diameter of the shell. And if you would like to make more than that, okay, more items, not 2 only. If you would like to make it for 10 items or more, it's applicable. So by using this tool, you have the ability to equal some parameters with each other. Like if we take a look to this video, for example, here we have an ellipsoidal head. So the inside diameter of this head, as you can figure, and it is different from the shell inside diameter. By using the parametric relations, we will generate a new relation between 2 parameters. At the beginning, we need to here we need to define the first part, which is the left head. Okay, this name is indicated here on the tree. It's the left head, and the second element is shell. So by using this tool, we will select the first element and select the required parameter, which is the inner diameter of this ellipsoidal head. Okay, so after selecting and double clicking on it to appear here, okay, so this parameter is selected now, and we will go to the second side and select the shell. Okay, and after selecting the shell, we will select the inside diameter of the shell. So now we will make a relation between them and make them equal each other. Okay, you will click on mapping and close this form. After that, we will define the inside diameter of this ellipsoidal head. So we will change it to 1500 and come back to the shell. You can figure that the diameter is changed automatically. The same we can do it with other parameters like thickness. For example, if we open that one and select the thickness in this case, and from the right side we will select the thickness. Okay, so we will make a relationship between the thicknesses for each item. So you have a new equation for the thicknesses. So automatically, in case of changing the thickness of one of them, it will be reflected to the other. So let's come back to the left head to figure out that we change the thickness of the head. In heat exchanger, we will automatically generate the relations between elements. Like, for example, if you have a connected flanges for the channel, for example, the blind flange and the connected flange and the gasket. So some of those relations will be generated automatically, like the outside diameter of the flange, they should be the same. If you change it in one side, it will be changed on the second side. The bolt circle diameter, the inside diameter and the clearance, number of bolts, raised face diameter, and diameter of bolt holes. So those are a sample for relationships for some items. Okay, so in case of it changing the number of bolts in one side, it will be changed automatically on the second side. The inside diameter of the flange, the outside diameter of the flange, the number of holes, all of that will be reflected. Okay. Now let's discuss some customization of elements and the varieties on SEG, which gives you the ability to create many different configurations. Here on the saddle in SEG software, you can figure that we have many different types of saddle, and in each type of those we have a different cases. You can figure that on the first type here. We have outside ribs, okay, and for the second type we have the web of this saddle includes a straight edge to the center of the vessel, so this edge goes to the center of the vessel. And on the third type, the saddle straight edge goes down perpendicular to the bottom, so this edge is perpendicular to the bottom. And the last type, which is the saddle with a lifting lug. Actually, this type of saddle, it was a requirement from one of our clients. They are a heat exchanger manufacturer in Canada, and they are a great manufacturer. And they usually use this type for their heat exchanger, and they asked us to add this type to be able to use it in their models. Okay, now we will discuss the different options in each type. Okay, that's the first type of saddle, and you can figure that here on this saddle you have the ability to control the width of this web, and you can make it with the straight sides. So the straight side is an option, so you can make it with the straight side, so this edge will be perpendicular with the bottom. And if you would like to control the width, the bottom width of the web, you have the ability to do that. So you can make it with a narrow or a wide bottom width to control the BW parameter of the saddle. Another option here for the web location, you have the ability to make the web on the left side or on the mid side or on the right side. Okay, so you can control the location of this web, left, middle, or right. The same for the second type of saddle, which includes a straight edge which goes to the center of the vessel. Okay, this edge like that. You have the ability to make the sides with the straight sides or narrow or wide, and to control the value of this parameter. The same for the web location, to make it left, mid, or right. The third type of saddles with straight edge here to the bottom, you have the ability to do the same things to control the width and the web location. For the lifting lug saddle, the same options that we discussed for the straight sides or the web location. More options, you can do it on the saddle, like the saddle cut. If this area is tight, and you have the ability to tight your anchor bolt or the nuts of the anchor bolt, and some specs of manufacturer includes this cut on the saddle. So by using this option, you have the ability to make a cut on the saddle to suit the requirements of fabrication. You have the ability to make slot holes instead of holes, straight holes. You can make it as a slot hole. And if you have a saddle with a sliding blade, like you have a Teflon below it and another fixation, so you will not need holes, so you can make this saddle without any holes, so it's an option. You can control the pattern of the holes if you would like to make it on the short side, or you make it on the long side, so you can make a hole here or there or there. So you have the ability to make the arrangement of holes on the short or long side. Okay, you have the ability to add up to 9 ribs on the saddle. I think this number is fair enough. You can add those number of ribs to your saddle. Okay, the same we discuss this slide for the drawing. Okay, so let's close this and let's come back to some options for the type of licenses and the drawing options. SEG software is available the license of SEG is available in two different types. The first type, which is the hard key license, it's a USB stick, includes a license file. By connecting this USB stick to your machine, you will be able to run SEG software, and in case of removing it, you will not be able to run it. The benefits of this type of license gives you the ability to run SEG software in different machines, because this license is a jump license. You can move it from machine to another, so it depends on the USB stick itself. If you move it on another machine, you can run the SEG software on this machine. Okay. The second type, which is the internet license type. In this license type, you should be connected to the internet all the time, and your license will be defined by your information, like your email and the login information and the machine information. So in this type of license, you will not be able to change the machine unless you make a request to change your machine. Okay, let's take on the same day we can do it. If you would like to remove your old machine and replace it with another machine, you will make a new request, and we will give you the ability to use your new machine. But this type of license depends on the internet, so you should be connected to the internet all the time. You are running SEG software, and you will not be able to change your machine unless you send a request. Okay, that was our last webinar. And the last webinar we discussed some points regarding to the project assemblies, like if we have a stacked heat exchanger, and if we would like to make an assembly for this heat exchanger by using a tool of the project assembly and defining the spacing between equipments, we can generate the assembly of both heat exchanger to use it to create the final drawing for both of them, and generate the general arrangement drawing with multi-sheets. Some cases in large equipments, you have a large bill of material, so if you add it on the all information in one sheet in your drawing, like the views of the equipment and the nozzle table, bill of material, design data, all of that in one sheet, everything would be a lot of information in one drawing. And if you would like to separate some information in different sheets, you have the ability to do that by using a tool for making separate sheets in your drawing. And then on this session, we discussed how to create a general or the assembly for the jacketed vessel by making an inside vessel, which includes this coil, and we make this sample on this session. And if you would like to go through this session, kindly visit our YouTube channel. And in case of installing SEG in your software as a trial version, you have the ability to open the channel or the tutorial videos, and I will show you how to do that after after those slides. Here in this session, we did the inside vessel and the outside vessel, and by using the project tool, we generate the combination of those two vessels and generate the jacketed vessel, which includes the inside and the outside vessel. And by using SEG tool, we generate a separate template drawing, and discuss how to generate your standard template drawing, and if you would like to use it as a reference drawing for your projects. Okay, here that's how to create your border, and how to generate your title block. Okay, and by using this tool, which is the import reference template tool, by using this tool, you will be able to import your reference drawing and define some dimensions for your standard drawing, and you will be able to use it in your projects. And if you would like to change it from project to another, you have the ability to do that. Because you have some different information like the owner or the owner logo or the name of the project, so you can change your title block and border and make it as a reference drawing for your project. Okay, and we discuss on that session how to change. So you have the ability to change the units of your model and the units of your drawing. So you can make the units in fraction and control the fraction value. That's in case of inches. And in case of millimeter, you will make it on decimal. You have the ability to group. If you have different equipments in your project, you have the ability to make a group for the overall bill of material, or separate each equipment in a separate bill of material. You have the ability to make the size of nozzles in NBS or DIN and change the sort numbering configuration to generate the general arrangement drawing of the equipment. Okay. Here the exporting tool. So we discussed this on another slide, how to export the 3D model and how to save as your models on different extensions or your drawing in different extensions. Okay, so let's close this slide. The last one for the lifting lug. Here, for example, we have different lifting lug types in SEG. So you have the ability to select between of them to suit your case. For example, here for this type of lifting lug or that one. For this one, you have the ability to make this longitudinal lifting lug on the longitudinal direction and to control the dimensions of this lifting lug to change the shape. And you have the ability to add wear blade or cooler for this lifting lug. And if you would like to remove them, it's an optional, so you can do that. This type of lifting lug, so which is usually used on large diameter vessels, and that one for large weights. So you have many different shapes of lifting lugs, and in each shape you can figure that you have different options. For example, for this type of lifting lug, you have the ability to make this edge with a straight edge like this, or you can make it with this cut, and make this cut with fillets like this. Regarding to the end at the top here, you can make it with a fillet or make it with chamfer, so it's an option. Okay, so many different options in each type, and that will give you flexibility to create many different configurations. For example, for this type, you can make it at the end with a chamfer or with fillet. For the circumference and longitudinal direction, this type. Okay, another type for the cross lifting lug, so you can use this type. It's available in SEG. So if you would like to lift from one point by using those 4 lifting lugs, you will use this type of lifting lug. The Trunnion type, and the Trunnion type, you can figure that you have the ability to add our end blade, and all of that is optional. So you have the ability to add end blade. In this case, it's not exist. Okay, you have the ability to add a side ring, so you can figure that we have an side ring. In this case, it's not exist. This ring, you can make it 2 rings inside instead of 1, so you can add a 1 or 2 or not. The same for the external ring. you have the ability to add an external ring or 2 external rings. So many different options you can make it on the trunnion. Another shape of trunnion, which is that shape, you can make this is from this pipe from a plate or a standard pipe. You have the ability to control the orientation of this lifting lug, so you can make a change by changing this value. You have the ability to change this one. Okay, now let's start creating a sample. Now we have this SEG software, and from here let's generate a new project. By clicking in New tab, you can figure that we have this form for a new project, and you can figure that you have many different modules. The first module is the overall module. In the overall module, you will be able to generate all equipment, and all features will appear in this module, like the heat exchanger modules, which is a tube sheet and the other items. For the tanks, like the roof and bottom plates, it will appear. For ducts, the ducts shapes will appear. But in case of selecting one of below, only the features of this module will appear. Here you will define the name of the project. So we will make this demo. Okay. And from here we will select the location. So let's add this project on the desktop, and let's select the overall, and let's click finish. Okay, now we have that's the interface of SEG, and you can figure that that's the SEG tree, which includes at the beginning 2 levels only. The first level which is the project level, and in the project level you will need to define the project number, project name, some information here, and those information shall be exported to your drawing. Okay, by filling those data and click on save, it will be saved. Now we will go to the equipment level, and in the equipment level you can figure that you have the design data of the equipment, so you can define the information here. If you would like to remove all the checkboxes here, just from select all to remove the all checkboxes, and if you would like to select some only, like if you would like to change the code, and if you would like to change this design pressure, make it design pressure only and remove internal, for example, and change the units like this. So if you would like to make a modification, you have the ability to do that. Okay, after modifying, click save to save those information. And if you would like to import information from Excel sheet, you can make that by importing from the Excel sheet here. So you can remove all of that and import your data only. Okay, here from the visual tab, if we go to the setting tab and select the equipment setting, you have the ability to define the position of the equipment, which is horizontal, sloped, or vertical, and the direction of the assembly. If you would like to make the assembly from the left direction to the right direction, or from the right to left, and for vertical vessels, from top to bottom or bottom to top. Okay, here that's the delivered blade dimensions and the units of your equipment, the service tag number and serial number of the equipment. Okay, now if we select the vessel and go to the element tab, you can figure that you have the main elements that you can, by using it, you can generate the main shape of the vessel. After that, you will add the attachments. For example, the main, I mean by the main elements, like the head, shell, cone, body flanges. So that's the main elements of the equipment. After that, you will add the attachments. I mean by the attachment like nozzles, reinforced pads, supports, all of that means the attachment. Here, if we select the vessel, this and going to the element tab, you can figure that you have head, shell with the chamfered ends, cones, flanges, designed flanges for heat exchanger, blinds, connected flange, tube sheets, standard fittings like reducers, elbow tees, all of that. And for the others, you can figure that we have gaskets with bus partitions for the heat exchanger, suspension joints, eye joint for the saddle, valve, all of that. And for yes.
Yeah. Can I share one of the our PV-Lite file and you just show how you can fetch this SEG software? So that you can,
let him continue first. Let him complete it. I think that what is showing is some interesting. Once he completes it, then we can share it.
Okay. Here on the API elements for the roof, you can figure that the annular plates, compression ring, roof, arrangement roof, dome roof, many different types of that. Ducts, as we discussed on the, if you, in case of generating a new project, if you select overall, all of those features will appear. Okay, but if you select a pressure vessel, for example, the ducts features will not appear and the API elements will not appear. Some features like tube sheet will not appear. Okay, so in case of overall, all of that will appear. And you can select the tie as elements from the toolbox right here. So you have the ability to move this toolbar in different locations. So here you can add elements or fittings or others. So you can add elements from here or from this toolbar. Okay. Now let's add an ellipsoidal head, for example. Okay. And after adding this head, you can figure that we have more than 17 types of heads, like ellipsoidal head as half of ellipse, or ellipsoidal head with crown and knuckle radius, okay, or flat dashed head, a diffuser head, standard cab, and you can figure that the shape, you can get the shape from the image on the right hand side, the convex head, flat head, hemispherical head, for example, hemispherical head with negative straight flange, which usually used on division 2, conical head with 2 ends and the knuckle radius to the end, cone head closed at the end, or circular head. So many types of heads. Just select the head. After that, select the suitable type of head that you would like to create. From here, we will generate a head with 2 meters 0.5 and define the thickness, the straight flange length of this head, minimum thickness after forming, and the head ratio. And from here, you will change the material. So you can write it manually here, or by using the ASME database material, you can select the material from the list. So first select the table according to ASME and search for your material like SA516. So you can figure that the search get 4 types with a different grades. Okay, so just select the suitable grades that you would like, and here that's the UNS number for this material. And if you would like to make it an impact tested material or normalized, just select this checkbox. And if you would like to make any remarks, like remarks for this material in some extra tests will be done on it, you can add it on the remarks tab. Now let's click done to add the material here. So let's click this head, and from the assembly, let's click on assembly to start generating this head. Okay, you can figure that we have this ellipsoidal head now generated on Autodesk Inventor. Okay, now we will add, by the way, you have many different options on the head itself. For example, if you would like to make this head from one piece, you have an option to make it from one piece. And if you would like to make it from 2 pieces with a longitudinal welding line like this, kindly take a look to the image on the right hand side. So you have the ability to define the location of this longitudinal welding line and the orientation of this welding line. And if you would like to make it from segments like this, it's an option in the same head. So in the same head type, you have those options. So you can figure that easily in SEG it will gives you more flexibility to make the items and with different configurations to create the suitable element to suit your case. By the way, SEG CAD Solutions offer to generate the required elements for our customers for free. For example, if you have a standard internal or standard support or something like that, and you would like to add it to SEG library, like as we discussed the saddle for heat exchanger or the lifting saddle, you will send us the your spec with dimensions and sketches, and our technical team will work on that and add your spec to SEG software to be able to use it any time. Okay, and we are working now on a tool. This tool will give you the ability to generate your standard library, like in BDMS. If you are using BDMS or know about it, you have the ability to create your own standard library to use it in your work. Okay, now let's add another element for this head, like a shell. So let's add a shell. And here on the shell, if you select it, you can figure that you have many different types of shells. The first type is a pipe. Okay, and if you would like to make a shell but without any welding lines, as an indication, if you would like to make a fast drawing for one of your clients, and you don't want to make more detail, just a blade with all total length of the shell, so you can use this type of shell. It's without any welding lines, and you can control the length of this one by any length. Okay, the third type, which is the shell, this shell includes a welding lines in case of the circumference of the shell is small and the delivered blade dimension cover it. For example, let's come back to the shell here, to the vessel, and from the setting as we discussed here, that's the length of the vessel, the length of the delivered blade. Okay, and that's the width. That length will be rolled to create the circumference of the shell. If this value is greater than the total circumference of the shell, so one sheet will cover. But in case of large diameters or small value for the delivered blade length, so SEG automatically detect the number of sheets required to make this circumference. Okay, so and here you have a tool for the arc length. For example, arc calculation length. If you have a vessel with 6 meters, and if you would like to calculate the total circumference of this shell, so you will need 19 meters, around 19 meters for the total circumference. Okay, so this value, which is 12 meters, will not cover the circumference of the shell. Okay, so let's come back here and complete. So for the shell, you can generate this type of shell, which we discussed, and the shell with chamfered edges for the hemispherical head for division 2, or shell with different pieces. Those types, which is shell from different pieces and shell from different pieces and thicknesses, usually used for storage tanks. Okay, for the storage tanks, in some cases you may need to define each blade separately. So you will define the circumference length of each blade separately. And if you would like to define the thickness, you have the ability to do that. So you can make a blade with 4 meters length, for example, with thickness 10 millimeters, and another one with a different length and a different thickness. Okay, the second one. So that will give you the ability to control, gives you more control on the blades inside the sheet. Okay, so let's come back here and discuss the other types. You have the ability to add a pipe with thread end from start, end, or one side, and more options for if you would like to make a connection point for a nozzle, and we could discuss this those types on this webinar. Now let's come back here and select the shell and define the inside diameter with 2 meters point 5 defines the thickness and the longitudinal welding line orientation and the length of the shell. So for example, let's make the length of this shell with 5 meters. Okay, and let's click save. Now you will receive this message which tells you that the available length of the delivered blade dimension is 3 meters. Okay, because if we come back here and open the setting tab of the equipment, that will be the length of the course, and that will be used to make the circumference of the course. Okay, so if that's the delivered blade dimension, you have the ability to make a shell course length more than that value. Okay, so SEG will detect that and tell you that it's not a correct value. Okay, so let's come back and come back to select the shell, define the inside diameter and the length. Let's make it 3 meters, for example. The longitudinal welding line orientation, the gap, and the material, as we discussed, you can make it from here. If we click on Assembly, here you can figure that the welding line orientation of this shell comes like that on 45 degrees. Okay, now some more options on the shell itself. If you would like to make this shell with 3 or 2 or 4 equal plates, you have this option here by make it and enable segments. So by clicking on this button and defining the number of plates, so if you take a look to the image here, you can define the required number of plates, but in this case they will be equal. Okay, in this case they will be equal to each other. Now let's add another shell course. So from shell we will add another shell 2, and from this 4 you have the ability to make the shell blade looks like another old node on the tree. Here from this button you will select part same. Okay, and from this list you will figure that you have a shell 1, only shell 1, because we have only one shell blade. So in this case we will make this shell looks like that one. So all information here will be reflected there. And if you would like to make it dependent means in case of a change shell 1, it will be reflected to shell 2. Okay, but in this case we need to make some changes on the length or longitudinal welding line orientation, so we will not select the dependent on and select add. And if we come back to the shell 2, you can figure that the same information of shell 1 is here. So we will change the longitudinal welding line orientation a little bit and change the length of this shell course a little bit and click save. Now let's add another head 2, and by the same way we will make it looks like head 1. Okay, and let's click add. So if we come here, you can figure that the same information of head 1 will be reflected here. One or more option, we will discuss it after creating, which is the flip. Okay, you can figure that this option will be available in some parts which need to change the direction of it, like the cone or head. If you would like to make the large opening on the left side or make the large opening on the right hand side. The same for head. If you would like to make the convex of this head on the left side or make it on the right side. So let's create the assembly first. After that we will modify it. Here we create the second shell course. After that the last head. So let's take a section. Let's take a look. Now we have this head on the tree, but it not appears because of that. Let's take section here. You can figure that the convex of this head looks like the first one. So if we wanted to change the convex direction of this head, so we will use the flip option to flip the direction of the head. So we will click save here and flip the direction of the head. Okay, now let's add some attachments to the vessel and check out how we can add that and modify it. Okay, now we have this vessel without any sections. So let's come back here and select the head. And from the head, you can figure that you have many attachments you can add it to this head, like support skirt, support pipe, support beam, nozzles, nozzles with internal projection, weld ollet, coupling nozzle. The difference between coupling and coupling nozzle, this coupling is a coupling without any connections. But coupling nozzle is a coupling you can add connections to it, like add a pipe after that elbow, okay, etc. A stub outlet for the internal attachments like impingement baffle, vortex breaker, bus partition. For the head, you can add a platform, reinforced pads, insulation clips, lifting lugs with different types. So let's add a nozzle. So let's add N1, and from add we have this nozzle, and you can figure that we have different type of nozzles, like nozzle from pipe, nozzle from plate, long weld neck nozzle, or forged hub nozzle. So let's select a nozzle from pipe and select the size. Let's make it 6 inches, and from here change the scalable of the pipe. Okay, select the offset from the center line. So we will define the offset from vessel center line, this value. So we will define the offset of this nozzle. If you would like to make it at center, just make this value at 0, but we will make it with 750, and the orientation we will keep it on 0 degree, and keep the projection from here with 30 millimeters. The projection is the facing of this nozzle, and let's add a reband, and let's change the reband width like this, change the thickness, and define the surface of this nozzle as an inlet nozzle. Okay, and if you would like to define the nozzle load, you can define it from this 4. Okay, and let's click save. Okay, now this nozzle will be parallel to the center line and sit in nozzle. So let's add a flange to this nozzle. So we will select the external connection of this one and add in one flange. From here you can figure that you have many different type of flanges, okay, around 20 types or more. And from here we will select the suitable type, which is weld neck raised face according to ASME P16.5. And from here select the rating of the flange, the size of the flange, and the scalable. And let's click save. Now if we come back to this nozzle, and if we open the set welding detail, you can define the welding detail option of this nozzle. So if you would like to make the fillet weld value here, so you can define it from here, and let's make it 7 millimeters, and click save. Okay, now if we open the calculator, you can calculate the projection with flange from the seam weld line, not the tan line, the seam weld line, to the facing of the flange. So for example, let's make it 1 meter and 0.5, and let's click calculate. Now SEG calculates the length of that one. So the projection of this pipe, the projection of the pipe from here to there, this value will be 861. So we will need to minimize it a little bit. So let's make this value with 1 meter only, and click calculate. Okay, now this value is okay. We will accept this value, and you can figure that the projection is reflected here. Now we will make this assembly of the nozzle. And if you would like to make a preview for childs during creation, there is an option in SEG gives you the ability to make a preview for elements during creation on Autodesk Inventor. Here, if we come back to the setting of the equipment, and from here for the preview options, you have the ability to make a preview for the child during creation and the parent during creation. Okay, and some other options, we could discuss it, and let's click save right now. Here we will need to make another nozzle with internal projection, and on this internal projection we add some attachments. So let's select this head or select the shell, for example, and from here you can figure that you have many different attachments on the shell, like saddles, stacked saddle, leg, lugs, skirt, anchor chair, different types of cradles, nozzle with external projection, nozzle with internal projection, nozzles according to the API with internal projection and external projection, coupling, clean outdoors, well-lit stud outlet coupling, different types of lifting lugs which we discussed on the slide, external attachments like nameplate, external bands, ground lug, fireproofing, stiffening rings, ribs for nozzles, ladders and insulation rings, many different attachments, and for the internals, impingement baffles, deflectors, longitudinal plates, stiffening rings, trays, baffles, vortex breaker, pass partitions, platforms, and coils. Okay, now let's add a nozzle with internal projection. So from here we will select shell nozzle, and let's add a nozzle 2. For nozzle 2 with internal projection, you can figure that we have external and internal attachment. So in this type of nozzle, we will select. Let's select the nozzle from as a long weld neck connected with internal projection, or let's select a nozzle from a pipe or a nozzle as a connection nozzle. So you have many different options for the nozzle with internal projection. So let's select a nozzle from pipe, and let's select it as 12 inches, the size, the rating, the location, define the location and orientation. In this case, we will make this nozzle not a radial nozzle. Let's discuss some other options like hillside or tilted. So with the hillside, let's define the offset value from the center line, and let's add a rebad for this one. Define the thickness and define the size of this nozzle, for example, and let's click save. Here you have the ability to define the external projection or the internal projection, the direction of the offset. So let's make simply for this nozzle first. So in this case, you can figure that the child preview is running now after selecting the option of child preview. So you can see or watch each element during creation. Here we have this nozzle with an offset with 500 millimeters from the vessel center line. And if you would like to reverse and make it clockwise or counterclockwise, you can change this by using those options from the clockwise or counterclockwise from here. So let's make it counterclockwise and click save, and let's run the assembly and come back to the 3D model to check the changes. Okay, now we have this nozzle on the other side like that, and now we will add some attachments to this nozzle. Let's take a section here, and let's add some internal attachments to this nozzle. Now we will come back here and select the internal connection of this nozzle, and let's add some attachments. Like, for example, let's add an elbow into E1, and for this elbow, you can figure that you have many different types. Let's select elbow 90 degrees with a long radius, and select the size and the schedule, and let's click save. Now we will click on start assembly. Now we have this elbow like that. After that, you can add any attachment. If we would like to add a reducer, for example, so from internal, let's select a reducer into cone. Okay, and from the reducer, you can figure that you have standard reducer or standard eccentric reducer. Let's select standard eccentric reducer, and the size is 12, thickness is 14, and the end size, let's make it 6 inches with 14 here, and let's click save. Now let's click on run. So now the eccentric cone will be generated, and assemble to the model. Now you can control the orientation of the cone. If you would like to make the straight edge at the bottom here, and that's logic. But if you would like to make this, to control the orientation of this cone, from here, that's the eccentric cone angle. So you can control the eccentric cone angle from here. So if we make it 0, for example, and click on Start the Assembly, the straight edge will change, will be at the top like this. So it's not logic, but I would like to show you how to control some features of that. Okay, now let's make another attachment like a support saddle, for example. So let's come back here and select the shell, and from elements let's add saddle. And by clicking on saddle, you can figure that you have many types that we discuss on the presentation. Right here, we will define the height. Let's make it 2 meters. The saddle contact angle, let's make it 140. The thickness of the saddle. We will make the saddle with straight edges, as we discussed, straight sides. So the sides will be straight to the bottom. Okay, we will add a wear plate, and let's define the wear plate angle and the wear plate width, the thickness, and the fillet if you would like to add a fillet to the wear plate material, the base plate length. So let's make the base plate length like this, and the base plate width, the thickness of the base plate, the hole diameter, let's make it 40 millimeters, the hole offset from the short edge.
Mr. Ahmed, sorry to interrupt you, just one query. Is it not possible to get all this data directly from PVLite, or is it still not readable or in the development phase?
Yes, as we discussed on the presentation.
This is possible, no? You can read
yes,
it from...
Yes, it's possible. Yeah. It's possible. But I'm showing you the capabilities if you would like to make something from scratch on SEG. If you would like to make something like that. And here I would like to show you how many of items, because if I import the element, import the MDB file directly, you will not figure what I want to say here from the elements. Okay, so I would like to discuss that with you, and would like to discuss the different options and the different elements that you can add it if you would like to make something manually instead of using the MDB file. Okay.
Perfect. Just one thing, maybe you can just show us how you are adding the welding symbols. That's very much important for us as a fabricator. Because generally we get the many softwares are available, but most of the time we find the problem that those softwares are not capable of providing any welding symbols. So if you can show us this capability, it would be really helpful to understand that.
Okay, no problem. So let's delete this saddle and let's create a drawing for this equipment. Before creating a drawing, we will go to the setting tab, and from border setting, we will select the reference border, which is the SEG border, and click confirm. And if you would like to import your title block, you can add it from here and make it as a reference drawing. Okay, now let's create a drawing for this equipment. From drawing, we will select on create drawing. From here, you have the ability to select the size of the drawing. So let's select it as A1, for example. And from here, from the second tab, you will define the orientation of the views that you would like to show it on the drawing. Like the we will make two views, the elevation view and the right side view. And from here, you will define the spacing between them. Okay, and from here we will select the elevation view, the reference elevation view. Okay, from here if we take a look to the left view, okay, so in this form we will define the elevation view orientation. So if we select a left view, the left view will be the elevation view. Okay, so we need to make this view as an elevation view. And if you would like to make this view, for example, which is back view, as the elevation view, you will select back from here. Okay, so we will select the left view, and from the style, if you would like to make the drawing with all hidden lines or just with visible lines, Okay, you can select between visible or hidden lines. And if you would like to make it shaded with colors or not, and here you will define the location of the view, define the scale of the views, and from this tab, which is tables, you will select the required tables in your drawing, like bill of material, design data. If you would like to add a flange table, nozzle table, okay, fitting table, for example, if you would like to export those, and for notes, if you would like to add notes to your equipment, and if you would like to add it from an Excel sheet, you can do that. The welding details, from here you will find you have a library for the welding details. Okay, so you can select from it. From here, let's select this detail, that one, and let's select a nozzle with a reinforced band. So let's select nozzle with reinforced band and nozzle with reinforced band with internal projection. Let's select a detail for the wear plate of the saddle and any other vertical attachment like that, and let's click save. Let's add on some tables like client document list, and visual document list, like mechanical calculation, name plate drawing, general arrangement drawing, saddle drawing. If you would like to make a list for your drawings, you can make it from here. Okay, and from the title block, that's the revision table. Let's modify it. That's the first revision. Review, checked by and approved by. If you would like to add some empty rows, you can add it from here. The name of the drawing, the general arrangement, and the document number. And for the design style, in this tab, you have the ability to select between styles. If you would like to separate some information in a different sheet, like if you have a huge equipment and you would like to separate the bill of material in a separate sheet because it's a huge bill of material, so you would like to separate it, you can do that by using this tab. Now let's generate the detailed drawing of the equipment. Here that's the elevation view, and now we have the side view of the equipment, the revision table, and here's the bill of material, the design data, now the notes. After that is a nozzle table. Okay, pipe and flange table, client document list. Now the welding details will appear here. And if you would like to make a detail for as you ask for the welding samples, for example, if you would like to make a welding sample on a drawing, you are dealing with Autodesk Inventor, and it's a very powerful CAD software. So you can do everything you would like to do. Here from the annotation, and if we would like to make, for example, a detail for this piece or for this area, you can make a detail for that one. So let's make a detail for this one like this, and let's move it like that. And if you would like to make a section on it, for example, let's make a section, and from a spline, let's select the spline tab. Okay, and by using the breakout view, we will select this one and select the midpoint here and click OK. Now we have a section on this one, and if you like to add a weld sample here, so from weld samples we will select this one, and from here we just select this and right click and continue. You can figure that you have many options. At first we can make this one as for example, you can make it like this, and let's remove this one. Okay, so you can make it like this, and you can make full like this. Okay, so you have many different options. If you would like to make it with on field, for example, if you would like to make it on field or make it continuous weld, like that. And if you would like, for example, to make a fillet weld on this one, like that, so you have the ability to make this as a fillet weld with, for example, 7 meters as typical, and make it continuous. So you have the ability to do that. And in SEG, here you can figure that we make, by using this standard weld details for nozzles. For example, here, if we come to the nozzle table for N1, if we come back to the this table style, you can figure that N1 is according to NW3 welding detail, and the dimensions of the weld is 8 and 7 millimeters. So if we come back here, so N1 is according to NW3. Okay, so the A value and the B value is related to that table, which is 8 and 7 millimeters. By the same way, you can define it for the nozzle N2. In nozzle N2, we didn't defined it. So from the setting welding detail, we can change the value of the A. Let's make it 6 millimeters, 7, and let's say 5, for example, and click Save. Now, if we open the nozzle table here, you can figure that those values are changed, and the welding style, which is a welding style, is changed, which is NW7. Okay, so if we need to reflect it on the drawing, so in the drawing it's still as this. We need to update this drawing and update the welding detail to add another welding detail in it's here, which is NW7. Okay, but we need to reflect it on the table here, make this one NW7 and reflect the values. So let's come back to the drawing, and from here let's select drawing and create drawing, and from the tables we will remove all tables except the nozzle table. We will keep it, and from here we will click on update the tables. So by clicking on update tables, we will update the nozzle table only. So by clicking on save, okay, and click on create drawing, you can figure that the table drawing of the nozzle is changing now. Now it's filled with the new values. And if you take a look here, you can figure that the nozzle welding style is changing in W7, and the values become as you defined. So if you would like to separate this table and those welding details on a separate table, you have the ability to do that. And if you would like to make it manually like that, you have the ability to do that by making a view for the nozzle and defining that one. By the way, you have the ability to add the welding samples. For example, we have NW3 welding detail for the nozzle connection, so you can add it like this. So NW3, anytime if you would like to know what is NW3, you will come back to NW3 to know that it's a nozzle connection with a reinforced pad to the shelf, and here the values of A and B. Okay, so you can come back to the table of the welding NW3 for the nozzle, which is N1, to detect that the value of A and B. Okay, and if you would like to make it manually, you can do it like that. The same for the flange 2 nozzle. So let's add a sample from the standard blocks here. Let's add W1, W2, W3. Okay, so from here, if we select the samples and select W3, so to define the welding line of between the nozzle and flange, so you will come back to this detail for small thicknesses. And if you would like to make another detail for that one, you can figure that on the welding details table. You can figure that if you have double V, not a single V, if you would like to make it like that, or with cladding, if you have a cladding inside. So many different details you can select from between to export it to your drawing for something like that. Okay, I hope this point is covered now. For the bill of material, as you can figure, the bill of material is generated automatically without taking a time from you to fill it. It's just filling automatically. When you add, for example, an ellipsoidal head, you can figure that this ellipsoidal head definition or technical characteristics will be generated automatically. Here it's an ellipsoidal head to 1. The inside diameter is 2 meters 0.5. The nominal thickness is 10 millimeters. The minimum thickness after forming is 8 millimeters. The straight flange is 50 millimeters. The all data that you entered here, it will reflect automatically to the bill of material. Okay, the same for the material of this element and the weight of this element. Okay, for example, if you add a new element to the bill of material, if you would like to add an element from your side, not included in SEG library, you can do that by using the external bill of material. So you have the ability to do more things. Okay, I would like to notify about some important points regarding to the tutorial videos for the our channel. You can open it from this button on SEG to go through our channel here on SEG, and you can figure that we have a lot of tutorial videos you can learn from it. Our webinars by Image Graphics is included here. Some questions for our customers regarding to our webinars, like how to make a nozzle opening, how to make to add external part. Many different things you can figure out how we can do it. Like for example, if you would like to make a nozzle detail, how to make a group, how to make a nesting, all of that you can check it from our channel. And by using a tutorial tab, you have the ability to open our channel directly on SEG Software platform. So you can select the video from here and directly play it on SEG. Okay, so you can play the video directly from here, like that. Okay, if you would like to listen to something about that. Okay, and a live chat tool. So you can make a live chat with one of our technical support team. We are working for the technical team online chat, working for 4 hours per day. So if he is not connected, your questions will be sent by email automatically to our technical team by using this tool, and we will reply on it, or by using the bug report bug. If you have a question or something like that, you can, by using the report bug, you can send your request by using this tab. Actually, we need correct information from the user because the email that you will write it on the for your information, we will send on it. For example, for your profile here, from your profile, you will define the first name, last name, your company, phone, and your email. So we will use this email to reply on your emails. Okay. Any other questions regarding to that?
Mr. Ahmed, this was really a fantastic presentation. I think we were also looking at something solution like this. Earlier, what we have looked is not just a CAD software, but it is really customizable to our need. The only thing is, I think we are using UG NX, Siemens NX we are using. So only thing is now we have to look for the Inventor solution. Maybe so what the best to do, we would be taking a demo model, like a monthly from the Inventor. And maybe we will take and try to work out how is it fits to our. Maybe we have a 1 month some hands-on solution, and then we will come back to you with our actual need. But the preliminary, what we find, it is a really customized and excellent solution for the heat exchanger. But as our company process, we will try to evaluate maybe for 1 month, and maybe Inventor also. So once we combine with them, we will come back to form in detail, revert with our feedback.
Okay, no problem.
Fine. Thanks for your valuable feedback, Mr. Hardik. So definitely when you are going to install Inventor for trial, let us know. We will guide you how to install the SEG, and we can give you the evaluation license, and you can explore the software and then come back with your feedback.
Yeah. Okay. Do you have a tie-up with the Inventor? Like they can give you like in a one solution, we can get both the or SEG and or otherwise we have to separately take the from Inventor.
At present, you have to directly contact the dealer of the Inventor because we are not selling Inventor. We are only selling SEG.
Correct. Now, Okay, maybe we'll take the like somewhat
Yes.
1 month
But
model
trial
from
license,
the Autodesk.
trial license you can directly get from the Autodesk Inventor website. If you fill this form, you can get the trial license for 30
Correct,
days.
correct.
Yeah.
So I think we will work out of that. Like just maybe currently we have some load. Maybe after a month or so, 15 days, we will work on this. We will download the demo model from trial version from the Autodesk, and we will also contact you. But we are really interested in looking into this solution. It's really that's what we were actually looking for this. Unfortunately, we were thinking of that we have to make all these program ourselves and working. That's what once it's readily available in market, it was going to helpful to us. Particularly the program nesting program and generating CNC codes for the machine. That was also really a useful feature of this program. So we'll really look to it. Let's have the inventor downloaded, and then we will contact you for helping us into the just linking with this inventor.
Sir, we will.
Okay, it's automatically if you have Autodesk Inventor on your machine, SEG automatically detect that and run Autodesk Inventor automatically and send the commands to it automatically. Don't worry about that.
And we are having a cloud license also now. So maybe you just need to fill the informations on the internet, and then Ahmed will approve it, and you will be getting the license within a very short span of time. You can able to start using the license, the evaluation version. Okay.
Sure, Mr. Fawzan. We are looking to it. Just let us have the invent everything downloaded, and we will surely contact you.
Okay, no issues. Thanks
It
for
was
your time.
Yeah, it was really a great demo, and just we really like it.
Thank you.
Thank you so much for your time, and I hope this session covers some of your questions.
Sure. No, it's really going to be helpful to us. Just we need to evaluate and try work our demo. One of the exchanger, maybe what we are looking. Once we install your demo, we will put one of the heat exchanger, and just try to run it on your software, and just try to measure the productivity, how much it helps us to improve on it, and then we will revert back to you.